So my name is Stephen Roth again, and today I will be demoing the HVAC ResLoad-J app, and this is an iPad app, a mobile app that allows technicians and contractors, engineers, even architects to perform peak cooling and heating loads out in the field based upon the ACCA Manual J8 handbook. So it's mainly for residential and light commercial. So what I'll be doing is demoing this app, and like I mentioned, if for anyone who showed up late, feel free to ask questions at any time. Please make sure you're muted while I'm talking, and if you do have a question, unmute yourself, ask the question, then remute yourself. The background noise is very distracting, so just make sure that you do mute yourselves. All right, so what you see on your screen is my MacBook Emulator. So what's nice about the emulator is it allows us to, do testing of the app on the MacBook while we're developing it, but we can also do training. And this is what you see. You're looking at my MacBook and I'm sharing the emulator. So it looks exactly like what you would see on your iPad. And what I'm going to show you, I'm going to demo it in landscape mode. So what you see here is it's in landscape mode. Landscape mode, I think, is more conducive to using it out in the field, and it also shows more information. If I rotate it, into portrait mode like this, you have to click here and see the list, and I think for training purposes, it's much better to demo it in landscape mode. But just remember, you can use it in either mode. All the inputs appear in both modes. They're just situated differently. All right, so let's get started. And like I said, anytime you have a question, please ask. I want this to be an interactive demo. I don't want to talk the whole time. If you have really specific questions on something, please ask. I know a couple of you have emailed me over the past week, and I do want to make sure your questions are answered. All right, so on the left here, you see a list of projects, okay? And a project pretty much is a building, a home, a light commercial building, whatever. And as you select each project, then on the right, all the inputs for that project appear. And you can add new projects by clicking the plus button. And if you just type in a name here and click save, it'll actually create a new project based upon this default template that you see here. However, you can also copy existing projects. So for example, if I click copy from existing project, it will list all of the existing projects that I have. You select it and it will copy all the information from that existing project into your new project. So what's really nice about this is you can create a template. Suppose you have homes that are fairly similar to one another that you're servicing, where you can create one home template and then copy those. So you don't have to re-enter data over and over again. And it really is a major time saver. All right, so for the sake of speed and the fact that we only have about 50 minutes today, I do want to work with an existing project. Okay, so let's work with the Ross residence up here. So I select it, and like I mentioned before, on the right is all of the information associated with that project. And the way this app is set up is there's two main buttons up top. There's the block load and the room by room mode. So when the block load is selected, you're in what's called the block load mode. And basically you're treating the home as one big block, okay? And then the room by room mode is where you will actually enter information for each of the individual rooms in your home, if needed. So really, first of all, I mean, every project you'll have a block load. You just have to have it, okay? You have to have a block load. If you choose to do a room by room, you can do that after you've entered all your information for the block load. Because what happens is in the room by room mode, you actually derive your constructions that were created, your windows, walls, everything that you created in your block load will be, transferred into the room by room. Then you assign those different walls, windows, whatever, to your individual rooms. So if you think about it, when you're out in the field, most people, most technicians, contractors, engineers, really just want to get an idea of, how do I size my equipment? What's the size of my split system, or my, if you happen to have a rooftop unit, or my heat pump. You really want to, that's your main goal. However, if you want to get more detailed and you want to know the airflows in each of your rooms and even the loads in each of the rooms, then you would do a room by room. But most people out in the field really want to find out, what is my I want to select my equipment. I want to size my equipment. And that, to size your equipment, you need to do a block load. All right, then within each of these either block load or room by room modes, you have project, envelope, window, and skylight. Should be pretty self-explanatory. Project is your overall project information. And don't forget that you can always swipe screens. A lot of people forget that or don't know that. You can always swipe screens and you'll see more inputs. For your envelope, you can define all your walls, roofs, floors, doors, windows. Obviously, you define all your windows and glass doors, and then skylight. All right, so let's start with the project tab under your block load. So here I have my basic project information. Probably the most important input in this section here is your city. So if you click this little caret icon here, you can select a city which is, closest to where you're located, and then it will bring up the climate data or weather data for that city. And you can always override this data. So if your peak, summer dry bulb isn't quite 93, maybe it's only 89, well, you can enter the value of 89 for that. And it will apply only to this project. It won't override it for this city of Fayetteville, Arkansas. And there's about 1,000 cities in this database, both in the US and worldwide. And if you click the Map It icon here, it will actually bring up a Google map, and it will show a push pin of the weather data station that is in our database. So this push pin shows Fayetteville. So there's a bunch of push pins around here. You can select it, and it will then automatically, select the city that push pin represents. So it kind of gives you a nice little visual. All right, so now that we've selected our city, we have our weather data. Let's go down here to general inputs. So down here, we can select, our system type. And this doesn't really start affecting things until we may need a VAV system. And I'll discuss that in a bit. And then you enter your total floor area. And there's a couple of different ways to enter information here. You can actually go inside the text box. In this case, I'm doing it with my mouse because I'm on MacBook, but obviously on your iPad, you can use your finger. And let me actually bring up the keyboard here. Your keyboard appears, and then you can go ahead and type in a value. And you can see that there's a little slider control below this input. I can also move my slider, and that changes this value in this text box. So there's a couple different ways to enter data. Now you'll notice that the slider below is also moving in tandem with the slider above. And the reason is, in this case, most of the time, you're going to heat the same amount of floor area that you're going to cool. So in this case, they're moving in tandem. And you'll notice that the value here is maroon colored. That means it's a calculated or derived value. And you'll notice throughout the app that any values that are maroon means that they're usually calculated or derived. Now, you can always override this value. So suppose that you're actually heating more area than you're cooling in your home. So I can actually enter the value 3,500. And now you'll see that the values differ. And this value now is a black text, not maroon. So that means it's no longer derived. And so as I move this guy here, you'll see that the one below doesn't move along with it. So they're now not in tandem anymore. If I want to make it in tandem again, all I need to do is just erase that value from the text box, click done, and now you'll see they're in tandem again. So like I said, that's a general rule of thumb throughout the entire app. Any value that is maroon is usually calculated. If you want to override it, just go in and override it. Enter your own value, and it will override it. All right, so we have our floor area. You want to enter your average room height. So really the goal here is we want to calculate the total volume of your home. The reason is that is used to help calculate your ventilation load and your infiltration load. So the goal here is, it will take your cooling floor area times the average room height, and that will be your volume in cubic feet. So, if you specify this as your footprint, then you're going to want the total height of your home. If you're say you have a 2-level home and you enter the square footage, the total square footage of both levels, then this would be your average room height. So really the goal here is this value times this should approximately equal the total volume of your home. Total number of bedrooms here. Hold on one sec. Okay. All right, total number of bedrooms. You can enter, and you'll see that this value, number of occupants, is derived. And it's basically 1 plus the number of bedrooms. So as I change the number of bedrooms, you'll see that my number of occupants changes, and then once again, I can override the number of occupants if I want. Appliance load. Okay, so appliances are, you know, dishwashers, TVs, computers, stereo systems, anything that gives off heat, right? Or either sensible or latent heat. So low, you can just say, hey, you know what, I have about 1200 BTU per hour. Appliance load, medium is 24, high is 34. Now, I think we're going to, yeah, it looks like for the newer iPads, because of the resolution difference, we're going to have to change this little selector control, but this says custom. And what custom does is now you can actually enter your whole list of appliances throughout your whole home, and it will calculate the total sensible and latent loads due to those appliances. So if I select custom and then click the caret here, it brings up a new form, and now I can start adding appliances. So if I click the plus button, and then I click this caret here, you'll see that there's a whole list of appliances here that would be in your typical home. So let me enter a dishwasher, and I have one. And here's a suggested sensible and latent load due to that dishwasher. And, you know, let's assume that that dishwasher is used 25% of the time. Probably a little high, but let's keep it at that. So this is your total load, 1000 BTU sensible, 358 BTU per hour latent. And that will be my sensible and latent load due to the dishwasher. Let's add another item. Let's go to television. And let's say we have 3 of them. And what it's going to do here, there's no latent load, there's only sensible. And percent per hour used, 100% sounds a little high, but you never know. Some people like to watch TV a lot. Let's say the TV is on 25% of the time. And you'll see now it multiplies everything out, and that's the total sensible contribution to my home due to my 3 televisions. So pretty reasonable. All right, and let's do just one more item. And you can add as many as you want. And later on, excuse me, in the room by room, now let me take a drink of water for a second, hold on. And later on in the room by room, you'll be able to assign those individual appliances to individual rooms. All right, so let's do a computer. And you know, these days people have lots of computers. Let's say we have 4 computers in our home. The sensible load may be a bit high. I think the list that this comes from is from the ACCA Manual J8 handbook, and I think that list is a little antiquated because this computer monitor is assuming that most people actually have desktop computers, but I think the majority of people these days have laptops. So I think the loads would be a little lower for your laptop. But let's stick with this. So here is the total sensible BTU per hour for my 4 computers. And let's assume that they're used 50% of the time. All right, so I can go on and on, but you can add as many items as you want. And then click done, and it's going to display the total BTU per hour, sensible and latent, that's being contributed to the home due to my custom list of appliances. All right. On the right here, you see a pie chart. And this pie chart displays kind of a breakdown of my cooling load. And you'll see, you know, windows, glass, envelope, etc. And you'll notice that as I move my slider control here, my breakdown and my total cooling load and airflow change. So it's kind of cool that, you know, you can change these values with the slider and instantly see how your load changes. So this is for cooling. For heating, same thing. Then we have what's called our AED curve. So there's nothing there. Click the little calculator icon and it'll calculate the AED. So what is the AED? It stands for Adequate Excursion Diversity. And what that means is it's basically doing about a 12-hour profile of my cooling load due to Windows, starting from 8 a.m. all the way to 8 p.m. And you'll see that at 8 a.m. the load's at this, you know, fairly low, but then it peaks at around 2 p.m. and then starts dropping off. That totally makes sense. Because around, you know, late afternoon, that's when our glass load peaks. So this is showing our load profile. Now, what's the purpose of this? Well, you'll notice that there's 2 lines here. So if this peak value goes above this top line here, that means you do not have enough diversity if you selected a single zone package. In other words, you probably need a VAV system because there's too much diversity throughout your home, and you'll need a VAV system if this peak goes above the top line. If it's below or at the top line here, then you're probably okay with a constant volume system. So that's where the system type comes into play. You know, you'd want to change it to a multi-zone VAV if this peak was above that top line. So basically that's saying there's not enough diversity, or there's too much diversity, so that means I need a VAV system for this home. And we'll also notice, yeah, please go ahead, ask the question.
Yeah, what would you use for a multi-zone a package like a Mitsubishi system? What system in your pop-up? Because it doesn't seem to apply directly.
Are you talking VRF?
No, I'm talking about a heat pump system for heat and cool.
Yeah. So would there be would you have like how many? Would you have like a heat pump per floor, or how would that work? Would you have just one heat?
I've been using ducted units within the space and a single outdoor unit feeding for 3 or 4 or 5 air handlers.
Yeah, and is it a variable speed? Is the heat pump variable speed? Is it a constant speed?
No, it's all variable. It's either Mitsubishi or LG.
Mm-hmm. So what is your question again then?
So what would I pick in that system pop-up, because it doesn't
in the system type
directly apply to like a multi-split system?
Well, I might put a multi-zone split coil constant volume or a multi-zone VAV. I mean, I would select one of those. Thing is though, this doesn't affect your load per se, what you select here. All this does is if you select, say, single zone packaged and this goes above that top line, then it's just going to give you a warning saying, hey, you know what? You're not adequately diversified here. You probably need a multi-zone VAV or a multi-zone VAV system instead of a constant volume. So that's all this selection does. It doesn't affect your load, your peak cooling or heating load. Yeah.
All right.
All right. And then this AED curve is really interesting because we'll also see it in the room by room mode. You can actually have different AED curves for the different rooms. Because, for example, if you have a room facing the east, it's going to peak in the morning. If you have one facing west, the load will peak in the afternoon. So you actually have different AED curves for the different rooms. However, this AED curve here is for the entire home. So, if most of this home's glass was facing east, then, the AED curve would probably peak more in the morning. But because most of this glass is facing west or, south, it's going to peak more toward the mid to late afternoon. All right, so I'm going to swipe again here and let's talk about some more inputs. So here we can input our cooling and heating set points. And once again, I can move my slider control. And as I move my slider and change my cooling set point, you see how my load is changing, my cooling load. And then for my heating set point, you can see how my heating load is changing. My relative humidity, that really only affects my cooling load. And that's more my ventilation and filtration. And then my supply and heating supply, cooling and heating supply air temp, what these values do is these will really affect your airflow because, if you know the equation for total cooling load, it's equal to, 1.08 or whatever, depending upon your elevation, times the temperature difference, times your airflow. And the temperature difference is your set point minus your cooling temperature. So a lot of people call and say, hey, my airflow looks really low or looks really high. Well, then I tell them, well, why don't you go ahead and change your supply air temperature? Maybe your supply air temperature should be 50 degrees. If the lower your supply air temperature, the lower your airflow. So for example, if I change this to 50 degrees, and let me bring up the keyboard here, hold on. I'm gonna change this to 50, and you'll see how my airflow went down, okay? Or suppose I change it up to 60. My airflow will increase. So if you see that your airflow just totally doesn't make sense, or it does not satisfy the rule of thumb that you're used to, check out this cooling supply air temp, and that will change your airflow. Also, another thing people don't realize is if you're in Denver, you're at 5,000 feet up, that drastically changes your coefficient for this calculation. So rules of thumb that apply to sea level will not apply to Denver, Colorado, because Denver's, really high up there, mile high. And as a result, the airflows will be different because the coefficient for that equation is different. All right, let's move on. Construction tightness. If it's a new home, you'll want a tight construction, and this mainly affects your infiltration load. Average, if you're not sure, or if it's an average home, and then if it's a really old home that hasn't been updated in many years, 30, 40 years, you'll want a loose or semi-loose. And actually, let's do average. So my infiltration method. All right, so according to ACCA Manual J8, there's actually 3 methods, and I'm only going to go through 2 of them. The first one is the Manual J air change per hour method. There's the blower door method and the direct entry method. So the Manual J air change per hour method, it's basically what it does is it takes this parameter here, how many exposures does your home have? It takes that construction tightness that we just selected. It takes the total house volume. Remember, we entered that the cooling floor area and the average room height. Well, it takes that whole volume of our home, crunches the numbers, and calculates how many air changes per hour of infiltration that we have. And the equivalent is 63 CFM. All right, so, and then the direct entry method, if we know exactly how much infiltration, how much air is coming in through our leaky doors and windows, well, we can go ahead and enter that air changes per hour value right here, and it will automatically update our CFM. So most people use the Manual J air change method because it calculates it for you. I'm not going to talk about the blower door method. Not many people use it. It's pretty complicated. There is an explanation in the ACCA Manual J8 handbook that goes into excruciating detail on all these parameters, but that is one method you could also use. So same thing with heating. The only thing with heating, though, is you have an additional parameter, which is your fireplace. So if you think about it, in the dead of winter, your flue may be open, you're lighting a fire. Well, there's going to be some infiltration of air through your chimney down all the way into your home. So you do need to enter the number of fireplaces and what type of construction is that fireplace. So that's just for heating infiltration during the winter. All right. I'm not going to go through every single input here unless you have specific questions because there's a lot to cover. What I do want to talk about, though, is our ventilation. So there's 2 ways to determine ventilation. So ventilation is any outdoor air coming in through your furnace, right? It's not infiltration. Infiltration is different. That's what's coming from the outside, leaking through your windows and doors. Ventilation is actual air that's coming in through your furnace that you want to come in because you want to provide fresh air for your home, and that air will be conditioned, either cooled or heated. So you can do calc vent rate, and as you can see, because this is maroon, it automatically calculates the ventilation rate based upon a number of parameters, including your home volume, including whether you have any type of exhaust, and other factors. Manual ventilation rate is you can go in here and say, hey, you know what, I know that I'm bringing in around 20 CFM of outdoor air. You can just enter 20. And the value you enter here will then affect your ventilation load here. Exhaust airflow, if you have bathroom exhaust or an attic exhaust, you want to enter this here because it will affect your infiltration and ventilation. They're all interrelated in terms of, whether, how the load is calculated. Because if you think about it, if you're exhausting a lot of air, well, then you have a higher chance of a lot more infiltration because you're creating a negative pressure in that home. So then a lot more air is going to leak in through your leaky doors and walls because you have that negative pressure. If you don't have much exhaust, well, then you probably won't have as much negative pressure, maybe even a bit of positive pressure. So then there won't be as much infiltration. So all 3 of these values, your ventilation, your infiltration, and your exhaust interrelate with one another. All right, let's talk about duct. All right, so this is not a Manual D program. So you cannot lay out an entire duct system. We're in the process of developing one, but it's a little bit down the road. And it's
question on
fairly complicated.
Ventilation rate?
Yeah, sure.
How do you deal with if you're providing ventilation through an ERV?
Yeah. So where is it located? Is it in line with the furnace blower, or how is
No, I mean,
the setup of that?
Most likely using a separate system, either an LG or a Zender.
Mm-hmm. And
so that's a balanced system, essentially.
Yeah, I would enter the ventilation rate, and so is it being conditioned in any way? I guess is it removing the humidity or adding humidity, or what?
Well, no, the ERV unit should maintain the humidity level.
Yeah, maintain the humidity. Okay, so I would say.
I mean, I was assuming you would leave it at 0 if it's a balanced system.
If it's a balance, let me think about this. It's a balanced system, but you're bringing outdoor air in through that ERV.
Yeah, it's something between 85 and 90% of transfer of the heat across to the new air.
Yeah.
So I guess
I would say, yeah, you're right. I would say if it's balanced, then you ignore it, because all you're really doing is it's almost like a heat exchanger. So I would say enter 0. If you're not bringing anything through the furnace, I would say enter 0 for that ventilation.
Okay. Yeah, in this case, it's heat pump, so there's no furnace.
Right. Yeah. Okay. Yeah.
Okay.
So I would enter 0.
Or some small value maybe for the loss of the 10%.
A small value for what?
For the loss of heat for the 10% recovery. In other words, 90% recovery, so you're losing some heat. So maybe you put a small CFM value in there, like 10%.
Yeah, maybe a little bit. Yeah.
Okay.
Yeah, you may want to put a little safety factor in there.
So maybe like 10% of the value of the air being exchanged.
Yeah, so like if I enter, say 10, even if I enter 100 CFM here,
right?
Let's look at my ventilation. It's 4,000 BT per hour, so we're talking a third of the ton. Okay, so if I enter, say 20 CFM, we're talking just 825 BT. So it's not like we're adding no pun intended, a ton of additional cooling here. So if you want to add a little bit of ventilation just to up that load a little bit, just to cover yourself, then yeah, do it.
Okay. Thanks.
All right, so let's move on. Going back to the duct. So like I said, this is not a manual D program, but we do need to calculate our heating and cooling loss due to ductwork. So especially if you have an old duct system in your home that is not insulated, that is not lined, that is leaking a lot of air, it could add a tremendous amount of cooling and heating load to your system. I mean, we're amazed that when we do tests. Well, let me just show you. So here I can add as many duct systems as I can add up to 5 duct systems for my home. In this case, I have 1. If I want to add more, I click the plus button. And then I can do both a supply and return duct system. So let's talk about supply first. So these are all my parameters for my duct system. Where is it located? And you have about 6 options here. What is the general layout of that duct? Is it radial with outlets or trunk and branch? What's the configuration? Single, 2-story, 1 trunk, etc. The ceiling type. So if my duct system is, since it's in an unvented attic, it's going to ask me for the type of ceiling. Now these values here are actually ACCA construction types, so you would need to look in the ACCA Manual J8 handbook. And based upon what you select here, it applies a U value to that ceiling, and then it does the math in terms of calculating how much heating or cooling loss is applied to that duct system. The R value of any liner or wrap around my duct. Obviously, the lower the R value, the lower the insulation and the more heat loss or heat gain. Duct leakage. So you can go all the way from unsealed to sealed and tested. Let's do average. And then based upon my floor area, it's usually, if I actually delete this value here, it's going to calculate 18% of my floor area and apply it to my duct surface area. This may be a lot, so you may want to change this. Let's see what our load is. If I go back, click done, so my total duct load is 1.5 tons. That's a lot. So let's go back here. Let me just change a property here. I'm going to change this all the way to sealed. Let's see how it changes my load. And you'll see that it goes down to less than a ton. Someone is not, can someone mute themselves? I think it is Jeff. Can you mute yourself? Because we're hearing a lot of feedback here. Thanks. All right, so as you can see, I changed this duct system to sealed and tested, and it halved my duct cooling loss from 20 or 18 to about 10. So this really does, what you select here really does affect your load a tremendous amount. Suppose my R value goes up to R8. Let's see how that changes things. It's even lower, now down to 5,000 BT per hour. So as you can see, having a leaky duct system with very little low R value insulation really can drastically increase your cooling load, and same thing with your heating load. And then, if I have a return system, in this case, I don't, because I enter the value of 1, essentially means 0. So I don't have a return system, but if you do, you can enter your properties for your return duct system also. So just be careful, if you enter in parameters for this and you see that your duct loss is 2 tons or 3 tons, you should make sure that, yes, those parameters are correct, because that could drastically increase your cooling load and obviously increase the size of your equipment. So you really want to make sure that the parameters are correct for your duct system. Or you'll want to make sure to seal that duct system and apply a lot of lining or wrap to it, because it could be contributing a lot to your heat loss or heat gain.
Ducts within the house envelope, you discount?
Well, I'll show you. So as you can see here, you can say, where's the location? It could be unvented attic, it could be an open crawl space or garage, closed crawl space, unconditioned basement, or riser and drop in an exterior wall. So this is where you can specify where it's located.
Yeah, with the mini split ducted system, it's going to be within the space. It's going to be in the ceiling of a heated and cooled area.
Okay. So what I would do is so basically it's in the conditioned space. Is that what you're saying?
Right. So there shouldn't be any heat loss, right?
Yeah, there shouldn't be any heat loss. I mean, if you're in the conditioned space, it's assuming that you have a pretty good insulation and it's pretty tight, you should not have to model that system if it's in the conditioned space.
Okay, so you just leave that at 0 then?
Yeah. But if it was in an unconditioned space, like, in a crawl space or in your basement that's not conditioned, then I would say, yeah, you need to start modeling it.
Okay. Thank you.
All right. Yeah, no problem. So are there any other questions about the duct? We do get a number of questions about the duct system, just because people are just amazed at how much it can add to your cooling and heating load. So I just want to make sure you understand it. I'll move on, but if you do have questions, let me know. All right, so we still got a fair amount to cover, so I want to get moving. I'm going to swipe again here, and you can see a more detailed breakdown of my cooling and heating load, and it shows you, individual components with percentages, and these are also in reports, which I'm going to show you in a bit. All right, so let's select envelope. So envelope, now you can start entering all of your external walls, your partitions, your doors, your floors, your ceilings. You can enter all those. And once again, you click the plus button to enter a new envelope. You can copy from an existing envelope. So suppose you have 4 walls that are fairly similar, maybe the only difference is their orientation. Well, you can copy those and just change the orientation for any new wall. Once again, for the sake of time, I am just going to work with existing envelopes that are listed here. So as I select each envelope, on the right, all the information associated with that envelope displays. So let's look at our west wall. All right, so on the right here is information associated with my west wall. So here, for the envelope type, I can select what type of envelope it is. In this case, obviously it's a wall, but I can say, hey, it could be a partition wall, or maybe it's a partition ceiling. Let me leave it as an above grade wall. So one thing I want to make clear here is you don't need to model walls that are inside your home that are in between two conditioned spaces. You ignore those walls because there's no heat loss across it. So some people think they have to model every single wall in a home. No, you don't. The only walls that you need to model are the ones that are obviously facing the exterior of your home, and any walls that are maybe adjacent to a unheated garage, or maybe even a little warehouse or something that's unconditioned. So in other words, a partition. Other than that, you ignore walls inside your home. All right, so actually this is a west wall, so let me change the orientation to west. Construction number. So we have a full construction database in this app. All these constructions come from the ACCA Manual J8 handbook. And here we have three categories of walls: our frame wall, our block wall, and any alternative walls. If I select frame wall, then I can go through my list here. And on the left here is the ACCA Manual J8 ID or number for that wall. Then here's a description. And then below here, it shows you my U value for that wall. And then I can select it, click done. And what it will do is automatically fill in the U value of that selected wall and what's called the CLTD, or the cooling load temperature difference group, which basically is related to fenestration or solar load. And you can see this is maroon, so that means you can override this. So if you know that your wall has a specific U value, you can always override it. You can also override your CLTD value. Here you would enter your wall width and height. All the program does is multiplies these two values together, so 440 square feet, and then applies all the U values and CLTD, and it calculates our total load for cooling load for this wall. Individual wall is 1,300 BTU per hour. The heating load is 3,100. So let's look at south wall. Select south, east wall, and north wall. All right, so we have our walls. Let's look at the ceiling. So here I have a ceiling partition, and then let's assume that my ceiling is slightly sloped to the northeast, and I have a construction number. So here we have three different categories of ceilings or roofs. Okay, so let's say I have a roof deck, and I have a ceiling on exposed beams, 0.118 BTU U value. It automatically will fill in the U value here. I can override that if I want. Here I can enter the ceiling length and width, multiplies these two values, and then also the slope, because it is sloping a bit toward the northeast. So this is my ceiling. And let me change this just to external roof, just to make it more descriptive. All right, I can also model my front door. Here I can model, remember I talked about a partition wall. So this is a wall that's adjacent to an unconditioned space. So I can select partition wall here. The construction numbers are the same as my external walls. I can enter my height and width. And then here I enter the temperature on the other side of that wall. So in the summer, my garage gets up to about 95 degrees. In the winter, it gets down to 45. And it does the math and calculates our total cooling and heating load due to that partition wall. I can also model a floor. And there's different types of floors I can model. You can model floor slab. You can model floor, actually, I'll show you here. You can have a over enclosed floor, over open crawl space, basement, and slab on grade. So you have four categories. Then within each category, you have a bunch of different constructions.
On the ceiling, you mentioned before you can pick a slope.
Yeah.
If you had a gable roof, you would half the square footage and apply half north and half south, or half east and half
exactly.
west? Okay.
Yes. So you would pretty much have four different roofs, and
Right.
you would select the different orientations for each of those and apply the appropriate areas to each of those.
Okay, got it. And the U value, just to go back a little bit, if your wall is not listed, today they're requiring outside insulation, and those are different numbers maybe than what you've got on your choices. you would just have to do a calculation and come up with your own U value for your wall?
Yeah. U value is one over the R value. So if you know the R value of your insulation, if it's R30, 1 over 30, that's your U value.
Yeah, but then you've got the loss for the studs and all of that. So most walls have an outside insulation, which is continuous, so that's the full R value. But the wall cavity insulation would be reduced by somewhere around 25% for the frame.
Yes. Yeah. So you would have to kind of, do your own math there then.
Okay, good. Thanks.
Yeah, if I'm thinking correctly, I think you would add up the U value. I may not be right on this, but you add up the U values of each of those components in your wall, get a total U value, then do 1 over that to get your R value, or do you add up the R values of each of those walls and then do 1 over that to get U value? I forget how that works because I think they're either in series or in parallel. You know what I mean? But yeah, there's a way to do it where you add up all the components of your wall to get a final U or R value.
Yeah. Okay. Got it.
All right. So let's move on. So as you can see here, you have that same pie chart, shows you the breakdown. If I swipe, I just get that breakdown, which I showed you before. All right, let's move on to windows. So here, once again, we have our whole list of windows. You can add new windows. You can copy existing windows. So what happens here is I can add all, you basically create all the different types of windows that are on your home. And let's look at our west-facing window. So what makes it a west-facing? Well, basically what you're going to do is you're going to assign it or attach it to a wall that I defined under my envelope. That's what makes it west-facing. So see what happens here is when you assign it to that wall, then it's going to subtract out the area of that window from that wall. So I'll automatically do the math for you. And here I can specify what type of window it is, single, double, or triple pane. And then the frame construction, wood, metal, insulated fiberglass. And based on the combination of these inputs, it will automatically fill in my U value and my solar heat gain coefficient for that window. Once again, you can override those values. What type of window is it? Is it just a plain old window, bay or garden window? If you're not sure, just select default. Then suppose I have 5 windows that are on my west wall that are exactly the same size. Say they're each 14 square feet. Well, I can enter 14 just for one of them, and then just enter the value of 5. So all this does here is multiplies 14 times 5. So an important part of windows is shading, of course. So you can have external shading and internal shading. So in terms of internal shading, you have shades, so either blinds, roller shades, or drapes. And then you can specify what percentage of that window is being covered by the shading type. You can specify an insect screen, non-internal or external, and what percentage of the window is being covered by the insect screen. Here I can specify properties if I have a sunscreen. And if I have no sunscreen, you select that, or if I have a light, dark, or darkest. And then I can apply a sunscreen coefficient, which will automatically be calculated according to my selection, and then what percentage of my window is covered by that sunscreen. Here I have external shading. Ground reflectance, what type of ground is surrounding my home? That really does affect things because as the sun shines, it will reflect on the ground and then reflect onto your home. So if you have a type of ground that, absorbs that sunlight, then it won't reflect as much. If it really reflects a lot of sunlight, then it will affect your load. And then you can specify an external overhang above your window. So here you would enter your window height, the overhang length, and the distance above the window that the overhang is located, and it performs all the geometry calcs and basically calculates what percentage of that window is being shaded due to an overhang. So so that's it for the windows. And as you can see here, I've just assigned these different windows to the different walls. So really, you could have 20 of the exact same type of window. And maybe 10 of them are on your west wall and the other 10 are on your east wall. So all you would do is you would just, enter the area of one of them, enter the value of 10 here, and then copy this window to a new one, and then just change the wall it's attached to, and that's it. So, most of the time, your windows are fairly similar. It's just difference is in terms of their orientation and also maybe their size. All right, let's move on to Skylight. So Skylight.
On the windows, can I just ask if you've got
Sure.
if you've got value when you're window manufacturer, you can just plug those in. So if I have a U value of 0.27 and a shading coefficient of 0.46, I just put those numbers in and ignore the pop-ups?
Yes.
Okay.
Yep. That's what you would do here.
Mm-hmm.
All right, Skylight. So here, once again, you can add as many skylights as you want, copy from existing. Here we have our Skylight construction type, single, double, triple pane, and our curb construction. Based upon this combination of inputs, it will automatically input your U value and solar heat gain coefficient for that skylight. And as one of the callers just mentioned, you can also override these if you want. Enter the area of one skylight. If you happen to have one or two or three, you can enter the quantity here, and it calculates your skylight cooling and heating load. And also, make sure that you assign your skylight to a ceiling that was defined in your envelope, because once again, it will subtract out the area of your skylight from your roof. All right, so we've gone through most of the almost all of the block load inputs. Let's look at reports. So to do reports, you click the little pie chart icon and you have a selection here, system reports. These show a number of different reports. Here is kind of a cover page showing your basic demographic information and also your load summary, and also the mandatory language down here saying that this software tool is approved by ACCA. If you swipe, this shows you a bunch of checksum values. So, total infiltration air changes per hour, cooling load density, cooling airflow density. So a bunch of checksum values that you can look at. If I swipe again, here's my detailed cooling and heating load breakdown by individual components and also by percentages. If I swipe again, this is a room by room load. I'm going to show this. I'll show this to you a little bit later in more detail when I talk about the room by room. And here are my pie charts and also my AD curve down the bottom. And at any time, I can do a couple things. I can email these reports to myself or anyone, because what it will do is open your email client and attach these as PDFs, and you can email them. You can also air print these. So if you have a printer that is AirPrint enabled, you can print these directly to that printer. There's also, we'll talk about room reports later after a room by room section. You can email an HTML report, and what that does is that opens your email client and includes a CSV file, which you can open in Excel, and also includes an embedded HTML report in that email. So just a different type of report, and also allows you to import the information into Excel if you want to create your own reports. All right, the I button. The I button is mainly for settings. Most of the time, you're not going to touch this. Some people actually get confused with this, and we get called at least once a week. What people do here is they think that this input is actually the input for your home, but all these inputs here are just maximum values for your slider control. So let's look at this, because a lot of people get confused by this. I'm amazed. So as you can see here, my slider control for my floor area allows me to go to 0 to 10,000. So that 10,000 value comes from here. This value is not used to specify what your room or your home square footage is. All this does is affects the maximum value that's on your slider control. So most of the time, you're not going to touch these values. If you happen to have a home that you're working with that's 15,000 square feet, well, then you'll want to change this value up to say 20, just to give you some wiggle room, and then the maximum value, and I'll show it to you, well, then on your slider will become 20,000. But as you can see, it doesn't affect your room, your total floor area. All it affects is the maximum value. So like I said, most of the time I would not touch these values here. The only thing I would do is if on your reports, if you want to include your company information, you can enter that information here. And then the help icon here, this displays online help and also a video similar to what we're doing right now. But it does include pretty detailed online help. Plus, you can call us anytime if you have questions. All right, so we have about 8 minutes left, so I want to go through the room by room fairly quickly here. So we've done our block load, okay? So we've created all of our construction types, all our roofs, walls, floors, doors, windows, and skylights. In our room by room, we can start Oh yeah, and also in our block load, you know, we know what our total cooling load is. It's 50,000 BTU per hour, which is around, you know, a little over 4 tons of cooling. And then we have 2,100 CFM. So now we know, you know, we need a 4 or 5 ton unit to cool this house. So we're able to select our equipment. So now we want to go into room by room. And the reason we want to do room by room is we want to know airflows in individual rooms, because maybe, you know, we want to be able to size ductwork for these individual rooms if we're doing new construction. So here, once again, I can add as many rooms as I want. I can also copy from existing rooms. And as I select each room, the properties of that room appear on the right here. So let's look at the office. So within my office, I can, you know, look at some overall properties of my room. So here I can enter the number of people in that office, and that'll contribute to sensible and latent load for a person. Then if you remember those custom appliance loads that we entered before? Well, now what we can do is we can actually select from the list that we created and say, hey, you know, actually, we don't have a dishwasher in our office, so why don't we do a computer in our office? So remember, we inputted 4 computers in the block load screen. Well, let's apply one of those computers to this office. So what it's going to do is it's going to apply 540 BTU per hour of cooling load to this office due to that computer. So that's all we're doing, is we're able to now actually parse out all those appliances to these individual rooms. So here, you know, I can see at any time my total cooling load for this particular room and my total heating load. And here's a breakdown for my room. And then I can also display an AD curve for that room. So if you remember what we talked about, the AD curve maps the load profile from 8 a.m. to 8 p.m. And as you can see in this case, it peaks later in the afternoon. Now in this case, you'll notice that it is above this line. It really doesn't apply because we're just talking about one room here. We're not talking about a whole house. So you can kind of ignore the fact that it's above this line. Really, we're only concerned when this curve is above the line is when in the block load section. All right, so let's look at the envelope. So we can add as many envelope items to this particular room, the office, ceiling, floor, north wall, and south wall. So, you know, let's look at the north wall. So I add a north wall, and what I'm doing here now is this list here, the envelope type, actually comes from my block load section. So all of the envelope constructions that I defined in my block load are listed here, and now I can apply that envelope to this particular room. So in this case, I'm applying the north wall envelope. So if we go back into the block load, go into envelope, you'll see north wall. Go to room by room. I go to my office. I select the envelope, and I select north wall. I am now taking that north wall construction, and then I'm going to say, you know, of that total north wall that was defined in my block load, I'm going to apply, let's say, 100 square feet. So now 100 square feet of that block load, 100 square feet of that north wall is applied to this particular room. Okay. And then you can kind of see a little counter here. It's saying how much of that block load envelope is left. You can always go above and beyond this. So for example, if I entered 500, I could do that. It won't stop me from doing that. It'll say 0 left, but it kind of gives me a little indicator of the total block load area that I entered. So let's say we go back to north wall. I entered 370 square feet of north wall for my block load. Out of that, you know, and I probably applied it to a couple other rooms, there's only 120 left. But like I said, you can go above and beyond that if you want. So here is my load contribution to that north wall. West wall, same thing. Floor, I select the floor that I defined in my block load, and then ceiling, I select the ceiling that I defined in my block load. In this case, external roof. All right, so these are all the envelope items that are contributing to this office, and here you can see my breakdown here. Let's go to window. Same thing with window. I can create new windows, and then I can assign a window that I defined in my block load section and apply it to this room, to this office. So I'm applying the north-facing window to this office, and I'm saying 20 square feet of that window is applied to the office. Same thing with my west window. And then finally, skylight. In this case, there is no skylight in the office. All right, so let's look at the bedroom. Let's go ahead and assign a color television to our bedroom. So we have one television, and you'll see that 683 BT per hour. Envelope, we have a ceiling, floor, west wall, and south wall. Window, west window and south window, and then no skylight. Okay, so you kind of see how this is working here. What you're doing is you're taking all the constructions that you created in your block load and you're applying them to the individual rooms. And as you can see, we're getting individual CFMs for each room. For office, 277, bedroom, 245, kitchen, 380. Now we can start sizing our ductwork because we know our airflows for the individual rooms. So after we've entered all the information for our individual rooms, we can go and do room reports. In here, I can do a report for each individual room. So suppose I want to look at my office. It will display my total load, a breakdown for cooling and heating, and also my AED curve. And once again, I can email that to myself as a PDF or air print it. And I can also if I want to do all rooms, it will just display all the rooms, and I can just scroll and then email all of them to myself or to anyone. So those are the room reports. Plus, if you remember in our system report, there was a room-by-room report, which showed me all of my rooms, my cooling loads and heating loads, and airflows for each room. So this is a nice, concise report. All right. So that covers the block load and the room-by-room sections of the application. And are there any other questions, anything you want me to show you specific? I know, I think one or two of you had emailed me earlier this week and you had some specific questions. If you want to go ahead and, I didn't cover those, if you want to ask me and I can go through it. It is 1 o'clock my time or 4 o'clock Eastern, but I have no problem staying on a little bit more if there are additional questions.
Even on the floor?
Yeah.
Length of exposed edge. So is that just I assume that's just the exterior, just the length of the exposed edge of the floor?
Yeah, so what happens is it's only for certain type of floors, and I think, is it slab on grade? Yeah, so for slab on grade, certain types of floors, and this is all according to the Manual J8 handbook. If you select a type of slab on grade, what really matters is the length of the exposed edge. So basically, you're taking the circumference of the floor, of the slab, and that's how it calculates your heat loss, because that's what's important for a slab on grade type floor. So that's why it's asking you for that.
Okay, so that wouldn't apply to like a crawl space underneath.
No. So if we go back here, and if we had an open crawl space and select one of them, you'll see now that all we care about is the area, not the length of the exposed floor. So different parameters depending upon the construction type.
Okay.
Does that make sense?
Yeah, it shows up on mine for some reason on my iPad. Maybe my version needs to be updated.
What does it show?
Like I'm on a floor or construction floor over crawl space R13 blanket, and it does show the length of exposed edge.
Oh, okay. Well, let's look at that. Maybe is it a radiant floor? No. What's the construction type? The construction number?
19A-13P.
Okay, so that is 19A-13. So that's over enclosed. So I'm seeing floor length times floor width. Is that what you're seeing?
No, let me double check this. So I'm going to my envelope list. I'm on a floor, and I'm on construction 19A-13P, which says floor over crawl space R13 blanket.
19A-13P, because if you look at what
Oh, wow.
what I have here, is this what you see here, or are you seeing something different?
Okay, so click up. Okay, so you're over enclosed where I'm over open crawl space.
Oh, okay. But see, I don't see any 19s. I only see 20s.
Okay.
Are you sure you have? Because we have another version of this app that is not ACCA approved. It uses the same similar ACCA calculations, but it does have a slightly different list of constructions. Are you sure you're using that app? This same app?
I think mine is different than yours. I think I need to see about getting the other version.
Yeah, I think you do have. You probably have the version that is not ACCA approved, and that's probably what's going on here.
It's part of the NATE toolkit.
Oh, okay, that's why. Yeah, the NATE toolkit has the not. I mean, it does have a load calculation module, but it is not ACCA approved.
Okay.
Yeah. So if you want to touch base with me after the call today, I can get you upgraded to that if you want, so you don't pay the full price. I can give you my email real quick. sroth, S as in Steve, ROTH at CarmelSoft, same as our website, .com.
Okay.
If you want to email me, feel free. All right. So are there any other questions at all about anything in the app?
Yeah, I just sort of going over what you're doing here. I know this was kind of room by room, but I'm thinking on the block level. If I've got a 2-story house with a conditioned attic and an enclosed basement, how do I treat that in terms of, I mean, essentially you only have one floor in a building and one roof in a building, right? Isn't that the concept? So those are your heat losses through the bottom floor and the upper roof.
Yeah, so you're saying you have a conditioned, yeah, you have a conditioned attic, right? It's not an unconditioned attic. Yeah. So you would treat, so you have if you have 2 stories, okay, so above your second floor, you know, your ceiling of your second floor is below your conditioned attic. So you ignore that ceiling, but you would take into account your roof, obviously above your attic.
Right.
Yeah. And then, you know, if you have R30 insulation in that roof, and you would take that into account, and you would select, let's say here, if we have an external roof.
You would add floor area into your total floor area then. You would add the attic floor area as part of your floor area.
Yeah. Yes. Yeah. If you're conditioning it.
Let's say you had 1,000 square foot on the floor in a 2-story building, then you would say that there was also another 1,000 square foot of attic space.
Yeah.
But then your average height would be much lower, maybe in the neighborhood of 3 or 4 feet, depending on how tall your attic is.
Yeah, or you could just take the footprint of your home. So if it's 1,000 square footprint, and then times the total height of your home. So suppose the total height is, you know, I don't know, 25, 30 feet. So you would take 1,000 times 30, so that'd be 30,000 cubic feet. Okay,
I see. All right. And then how do you deal with a basement where we're using the perimeter wall of the basement? It's a brick and block wall, different from frame above, but that is the enclosed envelope. So there's a slab on grade in the basement, but then the floor above has a floor. I don't know how to count that. Whether you count that as over conditioned space, or whether you count it over unconditioned space.
Well, is your
loss is through 2 different floors, right? Which doesn't make sense.
Yeah. Well, is your basement conditioned? Did you say, or not?
It's probably going to end up conditioned, so I should calculate it that way.
Yeah. So if your floor is conditioned,
flood zone. So go ahead.
Yeah. If your basement is conditioned, then I would ignore the floor in between your first floor and your basement. However, obviously, the floor of your basement, you'll need to take into account for heating purposes. So you will need to add you can actually add, I'm going to add a new envelope here. Let's see here, what's going on? Oh, there we go. Okay. So I'm going to I can add a basement wall below grade.
All right.
And I'm not sure why. I don't think there should be an orientation unless, oh yeah, unless part of it's above. Oh yeah, below grade floor depth. So, and then, so basement walls, this is a list of different basement construction types. So here I can model my basement walls. And then what I can do here is I can enter the total area of all my walls, but you know, a portion of that basement wall may be above grade. So you'll want to enter the below grade floor depth because it will take into account, you know, any portion of that basement wall that's above grade. So this is where you would want to model your basement wall. Now your basement floor, let's see if there's floor, and then you can do basement floor here. And then you would select your basement floor type. And then what happens here is your basement floor, only heating loss is calculated, not cooling, because it's a basement floor. So there's really, you're not going to have any cooling issues. You just have heating. So that's kind of how you would model that.
And if you were to not condition that space, so it was enclosed and insulated but not conditioned, you would just treat the floor above like it's a heat loss to a
I would treat it as a partition. So if you would want, I would say treat it as a almost a partition ceiling in a way.
Okay.
In a way, it is a partition ceiling. So you would select flat construction type would be, you know, the closest that you could, you know, get in terms of modeling that, and then you would enter the area, and then what's the temperature in your basement, unconditioned temperature.
Well,
so I would treat it as a partition ceiling.
That's going to be a bit of a guess.
Yeah.
Yeah. Okay. All right.
I mean, in reality,
most
of your load in your home, especially these days, because homes are so tight and well built, most of your load is really your windows. You know, the fact that, you know, floors and, walls and ceilings are R30, R40 insulation. I mean, you're not getting much heat loss across that. It's really your windows that's adding to your cooling load. So that's what you have to be most worried about.
And I had one situation where, I mean, it's my understanding that in New York City, the heating load is going to should be heavier than the cooling load, but I'm consistently getting like 40,000 BTUs against 30,000 BTUs heating, which doesn't strike me as correct. So I think I'm going to go back through and see if I'm missing something.
I mean, I don't know. Can you really compare cooling and heating loads? It's just it's almost apples and oranges in many ways, because if you think about it, cooling load is really dramatically affected by your solar load, your windows.
Right.
Heating load is not affected by your window loads. In terms of solar, it's affected by the heat transfer, but not by your solar. So I would say comparing heating and cooling loads is kind of like comparing apples and oranges.
All right, good. But it's, you know, just my understanding on a conceptual basis that you're trying to cool from, say, 95 to 75 with a delta of 20, whereas you may be trying to heat from 15 to 75 with a delta of 60. So you would imagine the load would be higher. You know?
Yeah, but I mean, one you're talking cooling, one you're talking heating. So when you're heating, it still is different. I mean, if you look at your standard rooftop unit, you know, say a York rooftop unit or even a York split system, you know, usually they have a set cooling and heating load, cooling and heating capacity. That for your typical home, if you have, say, a 5-ton cooling unit, you know, you're going to maybe have 40 to 50,000 BTU per hour of heating. I mean, that's just typical. So you may want to look at some equipment selection for York or Lennox units and see what they say. You're cutting out there. Yeah, you're still cutting out, Bernard. Bernard, you're cutting out there. Why do you're really cutting out? You want to type in what you want to say? I can try to. Yeah, you're cutting out, Bernard. if you want to chat. Anyone else have questions? Any other questions out there?
Yeah, I have a question. Do you have a module to be able to do the duct design based on the calculations for the loads per room?
Yeah, that's a great question. We do not yet. We're working on a Manual D, which is also ACCA, but we do not have that yet.
Okay, and then I'm assuming that if you get the Manual D, then you would get a Manual S for the equipment and stuff, correct?
Yeah, we're working on that too. So we're working on Manual S and Manual D.
Do you have an ETA on that?
Yeah, it's gonna be a little while because we have to get approved, and it takes 6 months alone just to get approved by ACCA. I mean, it took us 6 months to get approved for this Manual J app, 8 years ago. So it could be a little while. Maybe the end of the year, I'm hoping.
Hey, Stephen, on a 2-story home or a 3-story home, you would recommend just doing it all on one instead of breaking up it in 2 different calculations, and then just considering your wall height is going to be a lot taller?
Yeah, well, it depends. How many different systems or units are you going to have? Are you just going to have one unit that serves that whole home?
Most of the time, but not all of the time.
So, what I would do, well, there's 2 things you can do here. If you're going to have, say, 2, suppose this is a very large home, 10,000 square foot home, and you have, say, 2 different systems, one serving the bottom floor, one serving the upper floor. You'd probably want to split your home into 2 projects.
Okay.
Okay. That's one way to do it. There's another way to do it. I didn't show this to you guys, but you go to the I button and you click multi-systems. What's going to happen now is when you select your project, it actually now slides and shows you can actually add multiple systems. And each system will have its whole own set of parameters to it. So that's another way to do it. If that's too confusing, or, you can go back and just say, split that home into 2 different projects. And what you can do is you create the first floor, enter all your properties, and just copy that into a second project. So at least you have all your constructions that are there, and then you just reassign them to your second floor.
Okay.
All right. Any other questions at all about anything? All right, going once, going twice. All right, so what I'm going to do is, like I said, I recorded this webinar. I will be posting this on our website early next week, latest, and then I'll send an email out to everyone with a link to that. And also feel free to email me if you do have questions that you couldn't think of during this webinar.
I do have one more question. How do I tell what version I have, whether it's the ACCA approved version or not?
Are you the one who was talking about the Nate?
No.
We got the Nate. Oh, do you see a little calculator icon in yours?
I do.
Oh, okay, so you do have the ACCA approved.
Oh, okay. All right.
Yeah. So the non-ACCA approved, I mean, there's a lot of differences, but the main obvious difference is there's no little calculator icon.
Okay. Cool.
Yeah. So you do have it.
Thank you.
Yeah, no problem. All right, so like I said, I'm going to record this, or I'm going to post it on our website, and then I'll send an email out to everyone. If you do have questions, just feel free to email me. Once again, my email is sroth, S as in Steve, ROTH, @carmelsoft.com, same as our website. And if there's no other questions, we'll end this webinar, and I appreciate everyone attending. Have a great day.